Hey everyone, welcome to another YouTube video. And in this video, I'll be talking about principles that are being followed while designing a good data architecture or a data pipeline. So basically in this video, I'll be talking about the AWS well architecture framework, Google Cloud's 5 principles, and also the principles from the fundamentals of data engineering. So without any further ado, let's jump right in. So what is this AWS well architected framework? So this is basically a document released by AWS on like what are the general principles and guidelines that you could follow to deploy a, a much more standardized architecture, software architecture on the AWS cloud platform. So these are the 6 general principles that one needs to be followed so that you could get the most out of AWS and the you could design an architecture that is like that takes more leverage of the cloud services that is being provided. The first one is operational excellence. So what does this mean is that operational excellence uh, it's the ability to support development and run workloads effectively, gain insight into their operation, and continuously improve services to deliver business value. So that is the description given by AWS. So in simple terms, you can say that operational excellence means that your data pipeline should run efficiently, and whenever you need to continuously integrate or deploy these kind of systems, then this operational excellence is a metric that one needs to follow so that you can deliver data pipelines that are highly operational and also provide good business value. And the next one is security. So whether your data pipeline is on premise or on cloud, and mostly the data pipeline that you will be designing would be on cloud as of now, because many businesses and companies are starting to leverage the services that are being offered by cloud providers such as AWS, Azure, and GCP. So in terms of security, you must build a robust system such that it could withstand malicious attacks from other networks. You should be able to build private networks with proper authentication and authorization so that there is no leakage in your data pipeline. And the next one is reliability. So your data pipeline should run consistently, and it should deliver reliable results. And this reliable results include the ability to operate and test the workload through its total life cycle. So if you are more interested, you could go through this entire document. I will attach the link in my description below where you could learn more about reliability and other principles if you are interested. And the next one is performance efficiency. So AWS in general offers multiple services, right? Like for example, if you have a big data project, you could utilize the EMR clusters, that is the Elastic MapReduce clusters, to quickly spin up a Hadoop or Spark cluster to run your big data jobs. Or you could also spin up an EC2 cluster, and then you could manually install Hadoop or Spark over it. And then you could connect the several EC2 instances over a network as well. So when should you choose EMR or when should you choose EC2 depends on your business use case. If you're willing to invest more in terms of your operational personnel, then you should go with the EC2 instances. Or if you want to deliver your project quickly and if you want to get results promptly, then you should go with a managed cluster to avoid all those hassles. And the next one is cost optimization. So there are many services provided by cloud providers, and uh, you need to identify which service is the best for you and which service will provide the more output for the optimal cost that you're investing in that service. And finally, sustainability. So sustainability, your system should be able to sustain changes, and you should be able to increase its efficiency across all the components by maximizing the benefits provided by the cloud provider. And in the meanwhile, you should also try to minimize the total resources required. So this is it for AWS well architected framework. This is the brief overview about it. And the next one is I'm going to explain about the Google Cloud's 5 principles. So the Google Cloud's 5 principles are: design for automation, be smart with state, favor managed services, practice defense in depth, and finally always be architected. So let's start with the first one. So design for automation. So you might be wondering, for every project, do you need automation? Well, technically, automation, it might sound a bit redundant if you're like initially developing your system, and it might sound time consuming that you have to have additional code or additional services that you need to do for automating your data pipeline. But the truth is, once your pipeline is automated, you could scale it way faster than people manually working on it. So what I mean by automation is that you could automate your infrastructure using Terraform, for example. You could automate your CI/CD pipelines with Jenkins or Argo CI/CD, uh, and you could automate your Hadoop or Spark jobs with orchestration tools like Apache, Airflow, or Uzi. And so that is why this automation is very important in the long run. And when you're scaling systems, when your business use case only has like 2 to 3 data pipelines, it may be fine to go with manual, but once you start to scale beyond, like, for example, 10, 15 data pipelines, this automation will come very useful because your developers don't need to manage them on a day-to-day basis. They could just automate them using these orchestration tools, and when there's an issue, they'll be working on it, obviously. But it does save a lot of time in the longer run. And the next one is be smart with state. So there are two things. One is stateful applications and stateless applications. Stateful applications require some form of memory retention. Stateless applications don't need that. So what is uh, if I could give a quick example for stateful, like when you're adding items in your Amazon shopping cart, and then like suddenly you refresh your web browser, and then you find all those items present in the cart, then it is a stateful application which retains whatever you added in the cart in the memory. But if the cart is empty, then it is a stateless application where the cart is not holding the data that you just added on. So a stateless application is very easy to scale up and down, or roll back to the last working state when compared with stateful application. And you need to know when you need a stateful application and when you need a stateless application. And the next one is favoring managed services. So, okay, you might be wondering this point is that Google is a cloud provider. They're obviously going to favor managed services, and maybe that's why they put in, like, you might be thinking, if you favor managed services, you'll be locked in a particular cloud provider, and you don't have the feasibility or flexibility to move on to different cloud providers if they offer better services. But truth is that if you go with open source, or if you just every time spin up computing clusters where you'll be deploying your code, you are not really taking the advantage of what your cloud provider is really offering. So you need to understand managed services such as like Google Cloud Functions or AWS Lambda or Google BigQuery or AWS Athena. They're all useful in helping you get results for your business without managing them or without having more operational personnel to uh, to maintain those services. So depending on your business use case, sometimes it is more wise to follow managed service or use serverless applications for your data pipeline. Next one is practice defense in depth. So just like in the AWS well-architected framework, you need to have good security protocols for a data pipeline. And finally, always be architecting. So not only data engineering or data architectures, the whole software field is a constantly evolving field, and there will be always something new in the market. So always be architecting. What generally means is that you should be aware of the latest trends that are available in the current market and how those new technologies could be used to leverage or produce good results for your business. So that's it for the Google Cloud's 5 principles. And finally, I'm coming to the elaborated points that were available on the fundamentals of data engineering book by Joe Reeves and Matt Housley. It is actually a very good book, and if you are starting out in the data engineering field, I do recommend reading. I do recommend you reading that book. It has a lot of things related to the fundamentals of data engineering that can help you know about the standard procedures and you know standard procedures and standards that are following in the market currently. So the elaborated points in this book, they have actually taken inspiration from the AWS well-architected framework and also the Google Cloud's 5 principles that I've shared, that I've discussed just now. So let's look at the points that they have added here. Choose common components wisely. Yes. So when you're designing a data pipeline or designing a data architecture for something that will be leveraged by the entire organization, then you have to choose the common components wisely. It's like, for example, a very simple example, if you're choosing AWS, then a common point to store data would be S3 in the object-oriented storage. So you could choose that as a common component, for example, that could be used by the entire organization. So basically choosing common components doesn't mean that each and every team should choose the common component actually. So if a certain team is working on a domain specific problem, then they shouldn't be forced to work on the common components just because it is there. And next one is plan for failure. No matter how good your data pipeline is, when you're continuously integrating and continuously developing, there will be points of failure. And not only failures, you have to make certain trade-offs. Like for example, in my older videos, I've discussed about the CAP theorem. CAP theorem is nothing but discusses about the consistency, availability, and partition tolerance of distributed systems. So what that theorem basically means that your distributed systems can only have 2 out of the 3 uh, available resources like CA or uh, AP or CP. So based on your business needs, you have to choose which 2 are required, and you have to make that trade-off. And uh, if your data pipeline fails, for example, then you need to understand like how long can my data pipeline stay in a failed mode. Like for example, if it is an internal tool, then it's fine. It could fail for a couple of hours, and your like business won't be impacted on a larger scale. But if you have a website and you have a payment gateway that fails for like 5 minutes, then it will create a huge business impact. So based on the use case, you should accordingly uh, develop failure mechanisms and disaster recovery mechanisms so that you could recover your systems quickly without causing much damage to your business. Architect for scalability, yes, sometimes when you have like uh, peak loads, then you need to have an architecture ready that is scalable. And when you are having an off season, or when the load time, when the number of users in your system is very less, than as you scale up, you should be able to scale down as well. So you should make provisions in your architecture for that as well. And architecture is leadership. Yes, a good data architect uh, will improve the standards of the data team that is working on. And uh, once the data team is mature enough, they could take on more complex problems, and uh, in future, they could also contribute to the data architecture and practice as well. Always be architecting the same thing that we have discussed in the Google Cloud's 5 principles, build loosely coupled systems. So yeah, you should build data systems that are loosely coupled. What I mean by that is that if your team is developing a software or a data product, then expose uh, the software output through an API or a pub subsystem, or uh, uh, just don't have a tight link system. So using API mandates, so building loosely coupled systems will reduce dependencies cross teams greatly, make reversible decisions. So making reversible decisions to uh, sometimes particular data architecture or software architecture might work, but sometimes you need to roll back, or you need to completely do a 180-degree or 90-degree change in your project. So in such cases, your architecture should be ready to uh, accommodate drastic changes as well uh, with minimal changes. I mean, yeah, I know it sounds confusing. So what I'm trying to say is that, yeah, if there is a drastic change in the business use case, your software architecture should be able to accommodate those changes with minimal changes in the software or data architecting pipeline. Prioritize security, as discussed in the AWS well architected framework, and also in Google Cloud's 5 principles. Importance of security protocol is always there. And finally, embrace FinOps. So many of you, I think, would be hearing this term for the first time. What is FinOps? It is financial operations. So it is closely associated with DevOps plus financial management. So why do we need FinOps? Why do we need this new term? So the thing is that cloud services on the long run, if not configured properly, they could be very, very expensive to your business. And it could even bankrupt certain startups. So embracing FinOps is very important when you're developing solutions over the cloud, and when you're leveraging those services, you should understand what is the cost of those services in your business and how you could reduce those costs and what services offer better value for an optimal cost and how you could utilize them. So yeah, these are the various principles that are generally followed in designing a good data architecture. And I hope this video is useful. I hope this video you found it useful and you were able to get a gist of what is all required when to be kept in mind when you're designing a data pipeline. So yeah, I hope you enjoyed the video, and if you do, then do leave a thumbs up and subscribe to my channel if you enjoy this type of content.